Hey everybody, welcome to another Probably Private. And today what we're going to be doing is we're going to be looking for the first time at diffusion models. So diffusion models, if you're not familiar, are where we put in text and we can get a photo. We can also technically use diffusion models to put in a photo and get a refined photo, but we won't focus on that today. And what we're going to do is we're going to try to see if we can figure out what was in the training data by using diffusion models and what we know about training data sets for vision. Okay, so we're going to be taking a look at two things. So first off, I want to show you a Comfy UI. So if you have never used Comfy UI, it's really easy to install and get started. They support a bunch of platforms, and it's basically a way of using diffusion models locally. They have pretty good support of most of the big diffusion models and pretty good integration if you download and have extra text-to-image results. And the UI can be a bit tricky to learn at first, but basically you're going to put your prompts in somewhere. There's negative and positive prompts. You can change your models here. You can change kind of the latent image properties. So this is basically the image that initially starts before the model tries to use the text to essentially find a good representation of what is in the text. You can also change seeds, play with these things. I'm not a vision expert, so if you're a vision expert and you have some tips, please feel free to put it in the comments. But it's pretty easy to use, even as a non-vision expert. At the end, you're going to run it down here. But what we're going to first look at is we're going to go back to Hugging Face because it's our friend when we're taking a look at what might be in the training data. And for figuring out what might be in the training data, a really useful data set is this LAION. I don't know how I should pronounce it, but this LAION relay 400 million, that's 400 million images scraped from the internet, like literally just scraped from the internet. So this is also another great place to go if you want to get out of your algorithmic bubble. Take a look at the images in here. And we have both the link to the image. Sometimes if the link is available, we have a preview of the image. And then we have whether it's not safe for work, some sort of similarity. I don't know to what. Then license is almost always question mark. Who knows? And then we have the captions. So these we can search through them. So if you're looking for particular types of things that you want to get good captions for, have a search through. But B, we can use this to try to figure out, hey, was this data set or something like this data set in the training data? Now, when we have that, what I literally can do is we can copy something over here. I already copied one. And if you want, you can have a look at other image data sets, so that's fine. But the stuff that's scraped from the internet is a good start, mainly because many models use those as starting points. And we can then decipher what was in the training data when we get a really useful match. Okay, so I already have one. I have one of a famous person, Party Pics, Sirath Malhotra, Katrina Kaif. Party hard in Glasgow. Okay, so we're going to run this. And when we run it, we can see a really cool thing about Comfy UI is it's going to show us what steps it's at. So you can also run multiple side by side. There's definitely a queuing mechanism for that. However, at some point in time, it will start to time out. Okay. And now here we have our image. And we can always then, of course, this model is not very good. That's why the faces look a little bit weird. But we can see, okay, we have people, we have dresses, we have faces, and we can compare that with our training data. So I have lost that exact one, I think. It's not on this page. So let's take a look at a second one. Let's figure out who this person is. Do we have an image of them? Okay. We have this image of them. All right, let's see. So that's the image. We have this Esquire photo shoot. Okay. Let's take a look. So sorry, Sita. We're gonna replace you. And we're gonna put this one in. So it's pretty short, so we may or may not get a good result, but let's give it a try. The longer the text that you put in, often the better type of image generation that you get. But we'll give it a shot, see if we can decode. Well, we definitely know it's in a car, right? Like you're seeing what I'm seeing. That's definitely a poor rendition of a car, right? And no sunglasses, unfortunately, but definitely got the jacket, right? Oh, wait, no, he's not wearing a jacket, but sure. Okay, so perhaps it's in the training data, perhaps not. Let's give a shot at least one more. I'm going to flip to a different page and we'll see if we can find a long one that we want to try to reproduce. Okay, the Meg movie wallpaper. That one we don't have cached. Let's take a look. What's this one? Well, it's the iPhone one. That's not a very good example. The ones that have like people's names or are more specific. Oh, that's the party pics. Hold on, let me show you the party pic. Wasn't quite exactly. If this is in the training data, there's enough other stuff. I mean, clearly it's him with some people around him. What's this one? All right, let's try. Seems weird. Halloween Kids Dental Clinic. What does it mean? I don't know. The internet is full of interesting information. Okay. If you know what a Halloween Kids Dental Clinic is, let me know in the comments. So we're going to run this. We're going to try to see, is this one perhaps in the training data? Seems kind of random. If not, we'll probably get a very scary image. And I don't think this matches almost at all what the image is. Let's have a look again. Definitely, it's also kind of has a lot of keywords that probably pick up other things. This is why people's names are really useful or really specific descriptions. Sometimes you'll find places where you can reproduce locations. So give it a try, play around. If you find good matches, feel free to comment or share your Jupyter notebook in the repo. And just get curious about how can we use images to potentially find what we think might be in the training data or not, and how can we reverse engineer that or perform attacks that essentially extract parts of the training data based off of this type of exercise. So have fun playing around and let me know how it goes. See you.